Let us now formalize the binary search algorithm. So for performing binary search, we need two pointers. We need to keep a track of the start and the end of the range we are going to search, right? So what do we call? So let's call the two pointers as low and high, which mark the start and the end of the range we're searching. So low is, and we'll initialize low with 0, which is the start of the initial array, and high, which is the total number of elements and the array, say n minus 1. Alright, and so now what we do is we compare the search value of the element located in the middle of the low and high bounds. Right, so we find the middle index, which is given by low plus high by 2, and then if the array value of the array in the middle, so the middle element of that range, is equal to our query element, then we have found the item. We just return the index, which is middle in this case. If the array of middle is less than the query element, then we update our range and consider only the upper half of the split. So what we do in that case is we update our low as middle plus 1. If the array of middle is greater than the query element, then we update our range and consider the lower half of the split. So in that case, we'll update our high as middle minus 1. So we will shorten our array to this side. So we continue the above process until we find the element we are looking for, which or when high becomes less than low. So this should never happen. When the end iterator, which is high, becomes lesser than the lower iterator, which is low, then in that case we were not able to find an element in the array, and we can safely say that the element is not present in the array. So let's take a look at an example. So we have a big array over here of size 10. So the indexes go from 0 to 9. Alright, and we have to search for the value to 23. So when we are searching for the value of 23, our initial low and high pointers are at 0 and 9, and we calculate our middle by 0 plus 9 by 2, which turns out and we take the ceiling of that because it is integer division. So in this case, which turns out to be 4, so this is our middle element. We compare 16 with 23. 16 and 23 do not match, and we know that 16 is less than 23, so we can discard this part of the array. Right, so once we discard this part of the array, we do not need to search any of this. So we will make our then we will update our low as middle plus 1, which is 4 plus 1. So our low has come here at 23. So that we have zoomed in over here. Let's take a look over here. So this is our new range. So in our new range, we want to again we have our low at 5 and our high at 9. We updated low as 4 plus 1. And 9 we did not high we did not change, so high is still at 9. And then again we calculate our middle element, which is 5 plus 9 by 2, which is 17 in this 7 in this case, I'm sorry, and then the element present at index 7 is 56, which does not match with 23. But now we notice that 56 is greater than 23, so anything greater than 56 we do not need to search, so we can safely discard this part and this part of our search, and then we focus only on this part. So now we will update our high pointer by making it equal to middle minus 1. Right, so in this case it will be 7 minus 1, so high becomes equal to 6, and low we do not update, so low is still at 5. Now what we do is again we search for the middle element, which in this case is going to be 5 plus 6 by 2, which is 5 again, and we see 23, and then 23 matches with the element we want to search for, 23. So in this case we have found the element and we return the index 5. We return 5 here, right? So now let's take a look at the pseudocode of the experiment, of the binary search pseudocode. So we take in the array and query element as our inputs or arguments to the function, and we need the low and high pointer to keep a track of the range, and this is we will iterate through the entire array until this condition is falsified. Alright, so we that is until my low pointer is less than or equal to high pointer, we will iterate through, or we will the array. So what we do is we find our middle element, which is calculated by low plus high by 2. We take its floor, or when it's integer division, we just do low plus high by 2, and then we check if array of mid is less than query. If it is that, then in that case we take the upper half of the array, which is, and in which case we will update low as mid plus 1. If the array of mid is greater than the query, then we'll take the smaller half of the array, which is going to be which will be reflected by updating high as mid minus 1. Otherwise, we check if the mid value is equal to the query element, in which case we return the mid, which is the index of our element found. If if we have not returned a mid element till now, then this condition the loop would have had broken out of, and then we return -1 in the case of when the element was not found. So that was the pseudocode of the algorithm of binary search.